physical and mental strength to perform a certain task.
What is it? Daniela?
Work is the use and mental strength to perform a certain task.
Physical and
mental strength.
Mental what?
Strength
To
perform
a test. Okay, that is most probably. Now another person, the definition for work.
Someone, you can raise your hand and share with us.
Any other person who has a definition for work?
I remember was Adrian, maybe. And
no one is raising up a hand.
It's Jovia Namuga, unmute.
Jovia, what is work?
Work is the product of the force applied and the distance moved by an object.
Is that
Of the force applied.
Of
the force applied. Applied. And the distance moved by the object.
And the
distance moved by the object.
By Namuga's definition.
Yes.
Okay, that is okay.
Other definition, ladies. Okay, there's Daphne Namugabo and mutant.
Teacher, can you tell that work is?
You give me your definition. Don't ask me. I'm asking, what can you say about work?
Time distance.
Work is it? Force times it? Distance. Is that your definition?
Yes.
Okay. Okay. Unless I have another definition.
There's no hand so far. Oh, the
okay.
There's unrest.
Unrest. What is what?
Application of a force to do a particular task.
What is it?
The application
of what?
Force to do a particular task.
Force to do a particular task. Are those the definitions which people apply or want to talk about? That is all. Okay, I'm going to start by looking at the first definition. Who gave me the first definition of physical and mental strength to perform a task? Let us look at what the definitions. One, the most important, what I've observed about these definitions, what is in common, we must be doing something. We must be able to perform something. That is when work is. So there is the idea of application. Sense. Are we together? There is an idea or application of something. I hope you get that point. Yeah?
Yes.
Yeah.
Now, you get for me your book and exert a force on it and you tell me what you happen to observe. You push something, and then you tell me what will happen, what you observe.
It's moved.
It has moved from its original position. Is that okay?
Yes.
Is that okay?
Yes.
So under normal circumstances, when we do work, as far as physics is concerned, a movement of that object from one position to another, the moment it doesn't move, there has been work done. Am I making sense?
Yes.
Yes.
The moment you don't experience a change of position, much as work is being done,
Teacher.
it becomes for us in physics to explain that in actual sense work has been done because of a lack of motion from one position. That is quite crucial when you are defining work in physics. So when you define work as mental strength, you are doing a lot of work. It is okay. And you are going to get tired doing that mental strength. But for us, you are going to find strength. Am I making sense?
Yes.
Am I making sense, girls? We are with work which you don't see, which is invisible. You are struggling right now, you are thinking, there's a lot of mental stress, you get tired alone. In physics, for us, your work is zero. Why? We have not observed you another. Is that okay? So in physics, I cannot define work as being a mental strength activity. No, that one has been ruled out as far as physics is concerned. Is that okay? Now, I'm going to Jovia's definition. Work, in most cases, as far as work is concerned, we are going to apply a force. Is that okay? Now,
Yes.
if it is okay, this force must cause movement of the object. Is that okay?
I can't hear.
So our definition for work in physics, as far as I'm concerned, definition. Okay? Let's go to share. No. Somebody's microphone is open. So work. So how to define work? So work is it? Read the definition for me. Work is what? Mr.
Work is the product of the force
What is
and
it?
if the point of application of a force moves in the direction of the force.
Is the product of
The force and the distance moved in the direction of the
the
force.
force. And the distance moved in the direction of the force. So our simple definition for work, it is a product of force and the distance moved in the direction of the force. Is that okay? That is how we define our work. So please note that as far as we are concerned, we must observe movement. So look at the video. What am I doing? Yes, they can see me. What am I supporting? A duster. Am I doing any work?
That's the
How many
You're
are
not.
me whether I'm doing work?
There is no distance.
Me.
Yes, who is you?
I'm Modine.
So Amodine, you tell me, why do you think I'm doing work supporting this duster?
I think because your wrist is holding up the duster.
My wrist is supporting the duster against what force?
I think
Against
gravity.
Gravity. Is that okay? Now,
Yes.
you are saying I am doing work. Now, those people who are, that is her explanation. Now, somebody who says I'm not doing work, can you give me your explanation?
yes, for me.
Yes,
I'm not
who is
doing
me?
work.
When you say me, just give me the name. There is nobody called
And
me. Huh?
you're not doing work because
Why?
you're not moving in any, I don't know, direction.
I'm not moving.
That
that okay?
the palm supporting the duster is not moving, and yet work is in work there has to be movement.
Motion.
There must be motion. Is that okay?
Yes.
Now, here I'm not doing work altogether. As far as I'm concerned, the moment I start moving this duster, that is when I am doing work. Am I making sense? Is that okay? The moment this duster moves from one position to another, that is when there is a product of a force and distance moved by in the direction of the force. Otherwise, here, when it is stationary, I have not moved. So the distance moved is zero. So the work done is zero.
But you've overcome the force of gravity.
Yes, I have energy. I possess energy. I have the ability to do energy. So what I'm doing here, that is potential energy.
Not kind.
It is not work. Am I making sense? The difference
Yes.
why I get tired, etc., I'm supporting something against a resistance, and therefore there is energy spent, but that is not work. Work is only exhibited when there is motion. Are we together? Because there will be a force applied, and then I'll have moved through a certain distance. Otherwise, here I have only a force, but it is not moving. Therefore, there is no work. However, there is energy. The moment I release this duster, what will it do? Let me release. This is what the difference is. And we are going to get the definition for energy. Suppose I move, you see this duster. The moment I release it, what is going to happen?
It will fall.
It will fall. Or it will do what?
Drop.
It will drop. So what is energy? What is energy? Girls, you know what?
The
How we define energy.
ability
Ability to do work. So this is what we refer to as ability to do work. The moment this duster is supported at a certain energy, it has potential energy. And the moment I release it, there are things that are going to be applied. There will be a force. What force will be pulling it down?
Gravitational
Gravitational force. And then if it pulls it down, what will happen to the duster? It will start
moving downwards.
And the product of that distance moved and the force applied will give us the work done. Am I making sense now?
Yes, teacher.
Yes.
So, if something is stationary, it has energy, it possesses energy, it has the ability to do work. what will that work, how will the work be done? The work will be done when that body is set off into motion. I hope we are clear, girls.
Yes.
Okay,
Yes,
so work is the product of the force and the distance moved by the direction in the direction of the force. So in brief, we usually use this data for work. I think that is
You're
we
breaking.
use F and we use D.
Times D.
force.
Times D. Is that okay? And that
Yes.
brings us to this triangle. For those people, remember we have three physical quantities. Imagine we have W, and this is F, and this is D. Is that okay?
Yes.
If I want to find the work, what do I do?
You multiply the force.
Force times distance.
Force times distance. If I want to find the force, what do I do?
You divide work and the
Divide
distance.
work and
If I
Work
want that
divided by
distance, what do I
distance.
do?
Work divided by force.
So that is our work. I hope that is okay.
yes.
Okay, what is the SI unit for what?
Joule.
Joule.
The joule. So SI unit is the joule.
Joule.
Please, we are summarizing these notes. We are picking up the major things. SI unit of work is the joule. And it is I and capital J because it is somebody's name. I hope that is okay, Mr. Sadi. Mr. Sadi, okay. So what is a joule? Define a joule.
A joule is the work done when the point of
Who is speaking? A joule is the
work done when the point done
when
an object is moved in a distance of 1 meter.
When what?
When a force of 1 newton moves through a distance of 1 meter.
When a force. When actually, when the point of application of a force moves through 1 meter, isn't that the point of application? When a force, is it when a force of 1 newton moves the body through the distance
Direction of the force.
of 1 meter. That's why I prefer the other whatever. 1 meter. I prefer the other whatever definition that this is work done. But when the force of when the point of application of the Newton when the point of application of the Newton of a force of 1 Newton moves through a distance of 1 meter. I think it is usually a better definition. Okay. The joule is the work done when the point of application of the force of 1 Newton moves through a distance of 1 meter. That is okay. Okay, girls, that is our definition for the joule. Is that okay?
Which one should you take? The one in the notes or the one that you've written?
What is the one in the notes? You give me the one in the notes.
It says
I
a
don't
joule is the
application.
Is that then when the point of application of a force of 1 Newton moves through 1 meter in the direction of
when the force when is the it is a better one. It is the work done when you give me that one in the book
when the point of application of a force.
Point of application, yes. Point of application. Point of application of a force
Of 1 Newton moves through
Newton.
1 meter.
Moves through this moves what?
Moves through 1 meter in the direction of the force.
1 meter in the direction of the force. In the direction of the force. That is the better one. Thank you, guys. That's how we define a joule. Is that okay? It is the work done when the point of application of a force of 1 Newton moves through 1 meter in the direction of the force. That is our definition for the joule. Is that okay, girls? Are we okay? Okay. If we are okay, I'm going to ask Mr. Kugonza to take you through those notes. I want to move out of this one. Sorry. Just put it. Why say yes? Mute all current new participants. No. I don't want to mute. Just yeah. Okay. So let us now, we have made our definitions. Let us look at this. Factors which determine the amount of work done. Mr. Kugonza is taking you through that quickly.
Okay, good morning, class. Hey, good afternoon now.
Good afternoon.
Yes, so I'm continuing from, let me remove the mask. I'm continuing from where Mr. St. Jobe has reached so far. Also looking at what we have there in your notes. We want to look at what are the factors which determine the amount of work done. In other words, we have said, we have defined work as the product of the force and distance. So on what does it depend on? If you want the work to do a lot of work, what do you have to do? What do you have to do in order to measure your work as being a lot of it, a lot? What factors, what does it depend on? Yes?
It depends on the distance moved.
Depends on the distance. In other words, in order to do a lot of work, you must move what?
A longer distance.
You must move a longer distance. Okay? Now, so distance.
The distance moved.
In other words, the longer the distance,
the more work done.
The more work done.
The longer the distance, the greater
work done.
Amount of work done. Okay, so what that means is that supposing that both of you are before me, I'm okay, you can't see this box, but let me raise it so that you are able to see. You see this box, this block here?
Yes.
Now, if I push it by a force, let's say the force is 5 newtons, the force is a constant. If I push it by a constant force, and then it moves a distance of 2 meters, then another person also pushes it by the same force, and it just moves a distance of 1 meter. So who has done a greater, which of those would indicate a greater amount of work done?
The
one who moved the longer distance
of 2 meters.
So the longer the distance, the greater the amount of work. Okay. Now, secondly, what is the other factor?
The magnitude of the force applied.
The magnitude of the force. Now, when we say that the work done, amount of work done depends on the magnitude of the force, it means that we are holding the distance constant, okay? We are keeping one factor constant. So if the magnitude of the force is a lot, is higher, The greater the magnitude, the greater the amount of the force will also be higher. The greater the magnitude of force, greater the amount of work done. So that is the reason why we are saying that work depends on those two factors. Okay? Is that clear? Now,
yes.
Because of that, work, we said that work can be measured. What was the SI unit?
Joule.
Joules.
The joules. See here, we said that the work is measured in joules. Now, joules also has other units which are related. For example,
Kilojoule.
if you're talking about a very big amount, now here we're talking about the quantity of work. If the work is too much, then you may not calculate it in joules. For example, if work done, if you have a force of 50,000 newtons and it is moving through a distance of 3,000 meters, what answer do you get?
Megajoule.
No. What is 50,000 times 3,000?
Oh. 100.
That is 15. 1, 2, 3, 4, 5, 6, 7.
151.
Oh. Okay. That is 150 million joules. You see that?
Yes.
So when we have an answer of this kind, instead of writing it like this, we can write it in other smaller units. We can have sort of abbreviate it, either as kilojoules or megajoules. Okay?
Yes.
Now, what is a megajoule? What is the equivalent? What is a megajoule equivalent to?
1 million. 1
million joules.
1 million joules. So yes. 1 megajoule is equal to 1 million
joules.
So what will 150 million joules be equal to?
150 million.
So you divide that 150 by 1 million. 150
megajoules.
150
divided by 1 million.
150 million.
150 megajoules.
50 megajoules.
150 megajoules. Okay, megajoules. So instead of writing 150 million joules, we can write it as that, MJ, 150 megajoules.
That is accepted in a paper.
Yes, it is accepted. But if the number, if the figure does not exceed 1 million, then you may not write work done in that format.
I use kilojoules.
If another form is the kilo, what we call the kilojoules. What kilojoules are equivalent to what?
1,000 joules.
1,000 joules. Okay. So, for example, if work done is equal to maybe 7,562 joules. You can write this as you divide this by 1,000. And what does that sound?
7.562 kilojoules.
And that K should be a small k, not a capital K. Okay? So that is how you either write as megajoules or kilojoules. Okay.
Yes.
Those are the major units. The other units are not so common when we are dealing with the converting into other units related to the joules. Okay. So Mr. Zenjobe is going to take us examples. Now I think we're going to look at some examples. Let's read through that first example. Do you all have those notes?
Yes.
Yes.
Okay. Somebody to read for us the first example.
A force of 10 Newton
moves a body along a straight path
A force of 10
and stops
newtons.
after 200 joules of work has been done.
What distance was moved?
Okay.
Solution.
Usually, when you have those examples, I usually prefer fresh examples that will make me think. Okay, we already have those ones, but we can handle those ones. So you have told me a force of how many joules? What's that force?
10 newtons.
10 newtons.
10 newtons.
Moves a body along a straight path and stops after 200 joules.
Of work has been done.
200 joules.
So work done. W is 200 joules.
What distance was moved?
Distance was moved.
Distance moved. That is a question mark. Is that okay? I already told you that for me, I go through those details. If you can, that is helpful. Is that okay? So you know what you're looking for. I'm looking for what?
The distance.
So my distance will be given by?
Work divided by force.
So my distance will be given by?
200 divided by 10.
And I must know the unit is in what?
Meters.
Is in meters. So the distance moved is 20
meters.
Is that okay? And please, it
yes.
is a good habit to say
distance moved is 200 meters.
20 meters.
20 meters. It's 20 meters. Much as most of us leave our answers here, but it is better you write a statement of your answer that the distance moved is 20 meters. Is that okay?
Yes. Yes.
That is our example 1. Example 2. Let us get rid of examples. In the examples that you have, we shall bring in the examples that we have from elsewhere. Okay?
Yes.
So example 2 is reading.
Johanna.
Yes, you read.
A tangential force of 15 newtons applied to turn a wheel of radius 70 centimeters about the circle described.
Are you okay, Johanna? You're the one reading, huh?
I want to see a
tangential force of
a tangential force of 15 newtons is applied to turn a wheel of radius 70 centimeters about the circle. To turn a wheel of radius 70 centimeters.
Applied to turn a wheel
about the circle.
70 centimeters.
About a circle.
How much work is done in 2 revolutions?
2 revolutions. So work done in 2 revolutions. So let me give you an idea, girls, about this illustration. We have this, that is the circular force. Is that okay? Is that okay, girls?
Yes.
You see this? Yeah. This is over.
It's okay.
Continue.
Yeah, okay. Now, tangential force is applied in that direction. It is going to be at right angles with the radius, and therefore this should be the center of our rotation. I hope that is okay. So this tangential force is describing what kind of, if we are talking about revolutions, what is the total distance that is going to be described here?
300.
So our work done, I hope you can see here, will be equal to the tangential force. Okay, I'll abbreviate it as force times the circumference times can this here number of revolutions. Is that clear? Circumference of wheel. Okay, the circumference of the wheel. This is tangential force times circumference of wheel times number of revolutions. If you have captured that, please tell us. This is very common when you are pedaling. Apart from pedaling, what else? Where do you apply this kind of tangential forces?
Driving.
When you are driving, very good.
When you're getting water from the well.
When you are getting, have you ever got water from a well now? But when you are getting water from a well.
That is COVID.
But it's okay. That is very true. When you are getting water
You're playing
from
with
a
the
well.
type.
But water from a well, for me, most of these things I know they pump.
That's above.
Okay? But it's a very good, anything that is rotating, that is how we're going to get our work. Thank you for those examples. So I'm going to remove this and you tell me what to substitute. So what is our force?
15 newtons.
15 newtons.
Our force is 15. So what done? Where is the, we apply the 15. Now our circumference, how do we get the circumference? 2 pi r, isn't it?
Yes, 2 pi r.
The number of revolutions we are given 2, isn't it?
Yes.
Okay, so 2 times 15 gives us 30 times 2. What pi do we use? We are not told what pi we use. The most appropriate pi will be
22 out of 7.
7. Is that okay?
Yes.
That's the most appropriate figure. Then this radius is 70, but we have to convert it to meters. Am I okay?
Yes.
Am I okay with you? Am I left anybody? I hope I am not left anybody.
Yes.
Yeah?
Yes, teacher.
Yes, you've left.
Teacher, no.
You've left.
No. Yes.
You've left me. You've left
Are you breaking in the middle? Just
the radius.
Radius there of 2 pi.
70 centimeters.
70 centimeters.
70 centimeters. So how do I convert centimeters to meters? Because this work must be done when the distance is in meters.
100.
Is that okay?
Yes.
Okay, let me put it here. R is equal to 70 centimeters, which is the same as R is equal to 70 divided by 100 meters. I think I did not capture that. Okay? Okay. So now we are reducing this, gives us a 10. This goes with that. So what we have, this is 0, goes with this. So we remain with the 3 times 22 times 22 times the 1. 22 times 22 times 1. That's what we have. So what is our answer, girls?
46.32.
231. And our answer is in what unit?
Because the direction is changing continuously. How does it? How is it consistent?
Person is applying the dimension force.
Because here we are saying the definition, which is force times distance in the direction of the force.
Until we are going back.
So with this force, that's what they.
Any questions?
Fine. Is it okay? Now, the reason why that answer is not exactly like this one is because the pi used there was 3.14 in this exam.
3.14 in the exam.
So there is that slight change, but this is the most accurate answer.
This was the most accurate using pi as prediction. Okay? Is that okay, girls? We have understood what that answer?
Yes.
This is question 3. Who's guiding us through 3?
Body of mass 5 kilograms raised vertically.
Okay, listen, wait a bit. For us, we want to put up our arms. So teacher Jambi has put up her arm to teach you the next question.
Okay, what does the question say? The next question. A body of mass 5 kilograms is raised vertically a height of 8 meters. How much work is done?
Asking for what?
Okay, so we are given the mass as 5 kilograms and the distance as 8. The distance is already in its units, 8 meters. But remember work done. Is force times distance. And when you look at what we have, I have the distance, but I have mass. So how do I convert this mass to force? Anyone with an idea?
Show me.
Yes?
I think you turn the 5 kilograms to grams, and then you use W is equal to mg, and then you get the force in Newton.
What are the SI units? Okay, I begin from here. W is mg. That is correct. Where m is mass. But what are the SI units of mass? Kilograms. So why should we change them to grams?
I don't know. Me, I just thought like that.
Okay, so we need to maintain m in kilograms, and then what does the G stand for?
Gravitational acceleration due to gravity.
What does G stand for? Okay, acceleration due to gravity. Very good. So my weight, which is a force, will be 5,
Acceleration due to gravity.
okay, which is 10. So this gives me 50 newtons. So this is the weight or the force that has to be carried through a vertical distance of 8. Therefore, the work done, distance. So now I have my force, which is 50. Then I multiply by the distance. It's already in the SI units, which is 8. What is 50 by 8?
400.
400, and what are the units?
Joules.
Joules, very good.
Very good.
That was question 3. Question 4. Do you have any questions on that previous number? Any queries?
No.
No. No, you know, we are a little bit many. By the way, there are some people there who have a tendency of keeping quiet. Okay, and we are
149.
49, but we are few. Some people have gone to where? We are very few. It is logging in. You are being locked out.
It's training.
It is raining. Okay. If you have said something, listen to people who are participating. Listen, can you listen to me?
Yes, teacher.
If you know you have been saying something, can you keep quiet and give opportunity to that person who keeps quiet?
Okay.
You know, here we are supposed to be like Jesus and go for that one sheep.
Yes.
So I'm looking for that one sheep. Please, if you are the sheep who is lost, help me find
Banji,
you.
Daniela.
Daniela, they have allocated you. These people who are very good, no. They don't want
Jolly
you to keep quiet.
patience.
Daniela. Daniela, where are you?
Audrey Comfort.
Who
Now we
else?
can
Joanna Twijukire.
Daniela, what was that, Daniela?
Banji.
Sanji Daniela. Let me look for Sanji Daniela. Even her name is
Jolly patience.
Daniela, I'm looking for your name because even your name is keeping quiet.
Betty
Daniela.
Nabukera Nicole.
These guys are just mentioning names randomly.
Irene Weber.
Yeah, now listen.
Okay, Band is not here. Who else is keeping quiet?
I'm to hire Letitia. I'm to hire Letitia.
Joanna Twijukire.
Letitia. Banange, these girls are not here.
Betty Nchege.
Tatiana. Tatiana Bugere.
Tatiana will give an answer.
Tatiana said something.
Yes, Tatiana Bugere said so. I was another student.
We want people,
Her name is Joanna.
By the way, we are taking time because we're interested in everybody participating at least. Jemima say something. Don't tell us that we did not try. For us, we have tried our level best. So we are going to go with the ones who God gave a talent of speaking.
Jolly patience.
Who? Petra? Petra.
Yes.
Petra, you are quiet also. This one. Monomumu is quiet. Petra. Petra, now I want Petra. Petra Aijuki.
Yes, teacher.
Petra, please, you guide us to the next number, yeah. Yes, Petra is the one who has been selected.
Number 5.
Number 4.
A.
Petra.
Calculate work done by an engine which exerts a force of 9,000 newtons over a distance of 6 meters.
Yes, good. So we are looking for work done. So what is our equation?
Our equation is work done is equal to force times distance.
Force times distance. And what do we substitute?
Substitute 9,000 and
9,000. And we multiply by 6. And what is our answer?
54,000 joules.
Very good. And there's another unit that was given there. I hope you know how to get it.
Yes.
How do you get that unit?
Shall we try in kg?
There is the kg. How do you get the kg?
Divide by 1,000.
Divide by
1,000.
So we get, so the unit can be abbreviated to kilojoules. Thank you very much, Petra. Now you are going to be telling me the girl you want to lead you in the next question. The first name I hear, you are the one guiding us. Who? Joanna.
Naranga Bonita.
Helen.
Joanna, they selected Joanna.
Mr. Sanjove. There's a question in the chat that says, why is it that sometimes we change the unit and sometimes we don't? On that final answer, I think you need to clarify why we sometimes we have to add the K. And then
the most important thing, girls, listen, girls, I'm clarifying. All other units, we don't actually care about them as long as we have a joule. The first important unit must be a joule. Am I clear with you?
Yeah.
Work is calculated into joules. Now, other questions may arise like this. Express your answer in standard form. Express your answer in kilojoules. Express your answer in megajoules. For me, what I'll mark first, I'll mark your answer in joules, then you'll do the conversion. If the conversion requires marks, it will be marked. If it doesn't require marks, it will be ignored. In case you have the answer in joules and you fail your conversion, I can still ignore your failure and I mark the correct answer in joules. Am I now clear?
Yes. Yes, teacher.
So our answer must first be expressed in joules, then we convert it to anything else that we want. I hope I've answered the question in the chat.
Teacher, does that mean you can also leave it in joules even if it can be?
Yes, you can leave it in joules. If there is no more requirement, it is okay.
So teacher, they can ask you to put it in kilojoules as well.
Yes.
Oh my God.
If you put it, then you convert it.
That means
you may want to make your answer smaller, so you convert. You can even write it in standard form. Can somebody write it for us in standard form? What would the answer be in standard form? (5.4) times 10 to the power what?
4.
Good. Power 4. And that answer will be in joules. That is still acceptable.
Teacher, in the previous number, you changed the distance to meters, but when you were learning about moments, sometimes you left it in centimeters.
We left them in centimeters because they were cancelling out, they are appearing on both sides over an equal sign.
Distance this side for anti-clockwise being equal to force times distance for the clockwise.
If a unit, they would cancel out.
Cancel the centimeters, cancel it this side. That is why, but here there is nowhere that they
here we don't have a cancellation.
Okay.
Mr. Sanjove?
Yes, Evo?
It's exactly 1. Maybe we can be concluding.
Hey. We are concluding with the last number. You know, these questions were selected to expose you to other questions.
these numbers you can be done namwe. Mumpe, who is reading for us number 5? Let us complete this small exercise in 1 minute.
Naranga Bonita.
Bonita, don't. We are going to jump number 6. I mean number 5. We are going to number 6, which has no working.
Yes.
Bonita.
Whoever is speaking loudest, you do the number instead of pointing fingers.
Yes.
Quickly.
Find the work done by a man.
Who is that one? Find the work done when a man of mass.
Find the work done by a man of mass 75,000 grams when he climbs 45 steps each.
When he climbs 45 steps each 10 meters high. Centimeters. 45 steps each 10 centimeters high. Okay. So quickly, we convert mass to what? Convert mass to kilograms. Can we do that? What do we get?
How do we convert the mass to kilograms?
75,000 grams.
75
kilograms.
25 kilograms. Our mass?
Our mass is 75 kilograms.
Divide by 1,000. Give us in kilograms, which is 75 kilograms.
How do we get that distance covered?
So if we have the mass at 75,
let us get the weight. The weight, which is our force.
700 times 10.
Okay, mg, which is equal to 75 times 10, giving us 750 newtons. Very good.
give me 4.5.
Yes. Now work done.
Work done, which is force times distance. What is our force again?
750.
750 times 4.5.
And our answer?
3,375 joules.
3,375 joules.
Thank you so much, girls. So we have looked at work and some of the many challenges or problems, calculations especially, that we can handle when dealing with work. For us, we want to sign out and we want to wish you a nice afternoon.
You too. Thank you.
Bye.
Bye. Thank you,
teacher.